Good morning. In this session, we are going to see about finite automata, types of finite automata, and conversion of NFA to DFA. First, we will see what is a finite automata. Finite automata involves state and the transition among the state in response to the input. By definition, we will see what is a finite automata. A finite automata is a collection of 5 tuple. It means Q, sigma, transition, Q naught, F. Q is nothing but set of state. Sigma it is nothing but a input alphabet. And then transition function Q naught is initial state, F is a final state. From the given example, we will see what are the state, what are the input symbols, and what is the transition function, and what is the final state here, and what is the initial state. So from the given example, Q naught, Q1, Q2, Q3 are called as a set of state which is represented by Q, and the input alphabet sigma is represented in this given example as a comma b, and the transition function. So in this given example, see, transition of q naught comma a, it reaches q1. This is a transition. Then transition of q1 comma b, it reaches q2. Then from Q2 comma B it reaches Q3, and Q3 transition of Q3 comma A it reaches Q3. So these are all the transition among the states, and Q naught is an initial state. Here the initial state is a starting state. So in the given example, the given transition diagram, the starting state is nothing but a Q naught only, and final state. In the transition diagram, the final state is represented by a double circle. So that is nothing but Q3. So till now we discussed about a finite automata. Now we are going to study about the types of finite automata. There are two types of finite automata are there. Deterministic finite automata is said to be a DFA, and non-deterministic finite automata is said to be a NFA. So first we want to know the difference between a DFA and NFA. So what is a DFA means? The finite automata is called a deterministic finite automata if there is only one path for a specific input from a current state to a next state. That means if there is a transition, see the given example, if there is a transition of q naught comma 0, it reaches q1, there should not be any transition of the same input 0 from q naught to any other state. So only in the definition they had given if there is only one path for a specific input from a current state to a next state. See, transition of q naught comma 1, it reaches q2, so there should not be any transition of q naught comma 1 to any other state. So if it comes, then we call this as a DFA. Whereas NFA means there is no rules. That means that the finite automata is called NFA when there exists a many path for a specific input from a current state to a next state. From the given example, see, there is a transition of q naught comma 0, it reaches q naught also, and also transition of q naught comma 0, it reaches q1. So this is given clearly in the definition. If there exists a many path for a specific input from a current state to a next state, we will call that as a NFA. So this is the major difference between a DFA and NFA. Now we are going to discuss the conversion of NFA to DFA. So convert the following NFA to DFA. See the given problem. That means the transition diagram is given. So in this transition diagram, we are having a 4 states. The starting state is indicated by that arrow mark q naught. That starting state is also acting as a final state, which is indicated by a double circle. So in the transition diagram, wherever the double circle comes, you had to know that act as a final state. So here the final states are q naught and q1. So our states are q naught, q1, q2, q3, and the input symbols are 0 and 1. Now first of all, before converting NFA to DFA, first convert this transition diagram into a transition table which is given below. That means that write that state Q0, Q1, Q2, Q3 and the input 0 and 1. Now mention the starting status Q0 by that arrow and mention the final status Q0 and Q1 as a single circle. Now see the transition. What is the transition of Q0 comma 0? See the above diagram Q0 comma 0, it reaches Q1 also, it reaches Q2 also. So transition of Q0 comma 0 means Q1 comma Q2. Whereas what is the transition of Q0 comma 1? There is no input transition. So write that as null. Next Q1 comma 0. Q1 comma 0 means it reaches Q1 and also it reaches Q2. So we had written in a transition table Q1 comma Q2. Next, what is the transition of Q1 comma 1? There is no input transition. So write that as null. Next, Q2 comma 0. Q2 comma 0 means there is no input transition. Write that as null. In Q2 comma 1, there is an input transition. It reaches Q1 and also Q3. So we are writing it as Q1 comma Q3. Next, Q3 comma 0. Q3 comma 0, it reaches Q1 and also Q2. So Q1 comma Q2. Next, Q3 comma 1, it reaches null. Nothing. So in this transition table, just see, is there any new states are available? How to find the new state? See, we are having only the fourth state Q0, Q1, Q2, and Q3. But from the transition, we had got Q1, Q2 together, then Q1, Q3 together. So this Q1, Q2 and Q1, Q3 are the new state. So if we got a new state, we want to compare that new state with the input symbol. So here in this question, the input symbols are 0 and 1. So what are the new state? Compare that with the input symbols called zeros and ones till we getting the existing state we want to find that. So first compare transition of Q1, Q2 with the input symbol 0. So see the left hand side transition of Q1 comma 0 union transition of Q2 comma 0. So what is transition of Q1 comma 0? See from the above table. What is transition of Q1 comma 0? It is nothing but Q1 Q2 union transition of Q2 comma 0. From the above table, what is Q2 comma 0? It is null. So if we union this, we will get Q1 comma Q2. So now only we are comparing Q1 Q2 with 0 and also 1. So I am writing that as a existing state. Now next transition dash of Q1 comma Q2, we want to compare that with 1. So what is transition of Q1 comma 1? It is nothing but null. And transition of Q2 comma 1, it is nothing but Q1 Q3. If you union this, we will get Q1 comma Q3. So this is a new state. So now you want to compare the new state Q1 Q3 with the input symbol 0 and 1. First I am comparing with 0. That means transition dash of Q1 Q3 and with 0. So see the left hand side transition of Q1 comma 0 union transition of Q3 comma 0 from the table. See transition of Q1 comma 0 it is nothing but Q1 Q3 union. What is transition of Q3 comma 0? Q1 Q2. If you union this, we will get Q1 Q2. So Q1 Q2 is nothing but a existing state. Next transition dash of Q1 Q3 with the input symbol 1. See whatever the new state we are getting, you want to compare that new state with the input symbols. So I am comparing now with 1. So transition of Q1 comma 1 union transition of Q3 comma 1. So both are null from the above table. So now we didn't get any new state. So we stops here and we are going to write the transition table of DFA. So see, just copy the transition table of NFA and write as it is for Q0, Q1, Q2, Q3 with the input 0 and 1. Write the same answer. Now we got the two new states. That means transition of Q1, comma Q2 and transition of Q1, comma Q3. So write that in the state column and what we got the answer. Just check that transition of Q1, comma Q2. While we comparing with 0, we got Q1, Q2. Write that answer. Then Q1, Q2 of 1, we got Q1, Q3. Write that answer. Q1, comma Q3 of 0, we got Q1, Q2. Write that answer. Then Q1, comma Q3 with 1. While we comparing with 1, we got null. Write that answer. I already mentioned for Q0, Q1, Q2, Q3, write the transition table of NFA. That's enough. Now, just we are going to convert this transition table of DFA into a transition diagram. So, see in this table also, we got a new final state. Already I told you that Q0 and Q1 is a final state. Now whatever the state combining with the Q0 or Q1, that state will also act as a final state. So here Q1, Q2 will also act as a final state. Q1, Q3 will also act as a final state. That means here in this transition diagram we got a 4 final state. The final states are Q0, Q1, Q1, Q2, Q1, Q3. Just draw the 6 states and name it as Q0, Q1, Q2, Q3, Q1, Q2, Q1, Q3. And from the transition table, see Q0, 0, it reaches Q1, Q2. From Q0 to 1, it reaches null. From Q1 to 0, it reaches Q1, Q2. From Q1 to 1, it reaches null. Q1 to 0, it reaches null. Q2 to 1, it reaches Q1, Q3. From Q3 to 0, it reaches Q1, Q2. From Q3 to 1, it reaches null. From Q1 to Q2, it reaches Q1, Q2 self state. Now from Q1, Q2 to 1, it reaches Q1, Q3. Then from Q1, Q3 to 0, it reaches Q1, Q2. From Q1, Q3 to 1, it reaches null. So after completing this transition diagram, just check, is there any transition from a starting state directly and or indirectly to all state. If there is no transition takes place directly or indirectly from a starting state to any other state, just neglect that stage. Just see in this transition diagram, from Q0, we are directly reaching to Q1, Q2 and indirectly reaching to Q1, Q3. But from Q1, Q3, again we are reaching to Q1, Q2 only. We are not reaching to Q1, Q2, Q3 from the starting state directly or indirectly. So I'm going to neglect that state Q1, Q2, Q3. I hope you all understand. And this is the conversion of NFA to DFA. Thank you all.